Okay, I'm going to walk you through the assignment 10 here on the robot particle filters. So you've hopefully downloaded robot particle filter start and done the participation project. So you're somewhat familiar with this. You know there's a particle filter group, and inside there is a particle filter class, and we're going to open that up and we're going to scroll down here to the bottom. Now in the participation portion, we uncommented the working version and commented this out, the student version. So if you remember from that, we should run this and it should do what it's supposed to. So let's just look again what it's supposed to do. I'm going to open up the main JFrame and again say run this as a Java application. And so we should be able to go around here. I find it helpful to take a couple steps forward until we're in this zone where we have a wall on one side, a wall on the other side, and we're looking straight ahead. So I'm going to go forward a step or two here. And then I like to see if I have any particles. If things are working well, I should have groups of particles around me. This looks like I don't have any good groups. It's like maybe I need to be using more particles in this example. If I go down now, do I have any particles following me? Oh, now it looks like I might have. Let's see if I can catch up to these ones that are down there. So again, we should see a group of particles right now. There's a question whether or not I'm at the end of this hallway or the end of this hallway. But if I turn around and face this wall, it should, and move towards this wall, it should start picking out my particles. So I've got a smaller group here, but as I go forward here and get a little close to this wall, it should realize that I'm not here, but I am here. So let's see if I can just turn around here and see. Do a couple more updates here. Yeah, so now most of the particles are now thinking I'm here. There's a small group that are over there. But this is what it should be doing, is grouping all the particles here. And again, when I first started, it grouped them. Let's just run this again really quick and see how it groups them. Even with the first update, I should say clumping pretty fast. So now I'm just going to do a quick forward step, and first they're distributed randomly all over. Now they're clumped. I do one more step and they should be clumped even more. Lots of clumping on even 2 updates. Okay, so I'm going to go back to the particle filter things. Now I'm going to uncomment, go back to this part where it says students can modify this version, and then I'm going to comment out the working version, because your job will be to recreate this working version. So the working version should be commented out here. And you can look at this code and see it's not written so it's that understandable, but it basically implements the algorithm. But I want you to do it in your own way. I don't want you just to replicate this code. That wouldn't be much fun. So right now what it's going to do is, so we've got a set of particles, an array of particles that we have. And we have 2 arrays of particles. One is we have a particle list already of particles that are built in. So if I go up to the top of this class, there's an array list of particles called part list. So part list is the current array of particles that I have. And num of particles is how many particles are in that array list. Okay, so I'm going to loop through all the particles for I equals 0, I less than num particles plus I. It's not maybe the most efficient way of looping through an array list, but for those of you who are not used to used to arrays instead of array lists, this will seem to make sense. So I is the value. So now I'm going to do is take a particle from part list and copy it to a new particle list called, what did I call a new particle list? Particle copy is a new array list. So I'm going to add the new particles to this particle list. But in order to do that, I have to do a couple steps. First, I get it from, I do part list.get, and using my index that I'm going to grab here. I'm going to grab a particle. And so what I'm going to do is just grab a random particle. I'm going to pick a random particle. So I'm just going to grab a random integer between 0 and 5,000, the number of particles. Set that as my index. And then I'm going to get that particle from my old particle list. And I'm going to save it into this single particle called P original. So I have two particles declared up here, P original and P new. So P original will hold the old particle copy, and P new will hold the new particle created. I've got to make a copy of this original, so I say particle P original new. I say new particle, so this calls a constructor, copies this particle. So this is how I copy a particle. I'm given a new particle, and then I'm going to add that new particle to my particle copy. So this loop goes for 5,000 times the number of particles. It grabs a random particle, picks a random index, copies that index, that particle, into P original, makes a copy of P original to P new, and then adds P new to particle copy. It does that 5,000 times for the number of particles. The number of particles is 5,000. Does that 5,000 times, and then when we're done, we reset the particle copy. We save over the old particle list and to the new particle copy. So this copies the particles over. Maybe I should have commented that. Save the new particle list over old one. But since I'm just picking random particles, when I run this, it's not going to do what I want. So when I run this, initially the particles are randomly distributed around Tower Hall. If I go forward, they will tend to still be randomly distributed. There might be a little clumping, but there won't be much. So they just kind of stay randomly clumped around. They turn right. There will be some clumping over time as I do this, simply because of the way that copies are made. But certainly they won't all cluster around me or any other place. So this is not doing what we want it to do. So rather than picking out an index randomly, you want to pick out an index based on a particle's probability. So each particle, let me bring up the particle class here. Each particle has a probability, and we want to use that to pick out particles for our particle list. So if we have P original, we want to be looking at P original.probability for our, like here we're getting, this is a little confusing, but here I'm getting from the particle list, I'm getting an index, and I'm doing dot probability to grab its probability and work with it. Okay, so how are we going to do this? What do we have to do? Well, let's just assume, let's just think we only had 5 particles. And their probabilities sum to 1, from 0 to 1 here. So let's say the probability of the first particle is 0.2, then 0.1, 0.1, 0.4, and 0.2. So that adds up to 1. And then, so this looks, I've stacked these all graphically just to kind of show how they are. And so we will choose particle 2 sometimes, but very rarely because it's a smaller probability. We will choose particle 4 more often because it is a wider probability. So one way we're going to do this is we're going to pick a number between 0 and 1. And once we have that number, let's say it's 0.623 or 32 or something, some number here, we just want to then try to figure out which particles give us that. So if we were to stack all the particles, how many would we have to stack to get to 0.63? So we would take the first particle, 0.2, and that's not going to get us to 0.6. And we take the next particle, 0.1, 0.2 plus 0.1 gets it all the way down to 0.3, and that's still not at 0.6. So we add the next particle, that's another 0.1. So now I have 0.2, 0.1, and 0.1 adds up to 0.4. It's still not to 0.6. And I add the next particle, 0.2 plus 0.1 plus 0.1 plus 0.4, that's 0.8. So now I'm down to 0.8, and now I've gone above this number, so then I should pick this last particle I have chosen. That's the particle I want to use. So again, another time I might pick a number like 0.23. That'll be in here. Let's say 0, oops, 2, 3. Yeah, it's fun doing this in Paint. Would be right in here. So again, I take my first particle, 0.2, that's still less than this, add in my next particle, that would be a 0.2 plus a 0.1, 0.3, and now I'm above this value, and so then I know I've got this particle. So a good way to pick particles based on their probabilities, when all their probabilities add up to 1, is to do this. Pick a number between 0 and 1 and then just keep going through the particles until you get to this random number you did. And you're going to have to do this again and again to repeat. So maybe I pick another number. Maybe this time I get a number down here and I go down and pick this particle. And then maybe I get 0.4. I'll pick this particle 4 a number of times, but also pick these other particles some of the time. So that's your job here, is to change this. Right now, when we pick an index, we just randomly pick it. We just say random.nextInt. Just pick out a random next int. Your job is to redo this. So rather than picking out a random index, you set the index. You loop through or somehow figure out which index would match based on the particle probabilities. Okay. And again, you can try it out and compare it to this working code here and get it to work. And you should see clumping and you should see the particle filter working. Now, the particle filter doesn't work all the time depending on how many particles you have and how you move around, but it should work most of the time. Okay, remember, post questions or hints for this to the discussion group, and good luck with this problem.